Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 7th, 2025, about 6 days ago. The big punchline is that this paper shows reinforcement learning can reach continual pre-training performance, using up to 100 times fewer tokens. The paper is titled Webscale-RL, Automated Data Pipeline for Scaling RL Data to Pre-Training Levels. And as we'll see later, the implications for model training are quite significant. It unveils an automated pipeline that turns pre-training documents into verifiable question-answer pairs, yielding 1.2 million examples across more than 9 domains, and it outperforms strong baselines by 3.4 points, with Math 500 jumping from 47.6 to 58.0. Alright, the introduction established the data bottleneck for reinforcement learning. Figure 1 presents the fix, a Webscale-RL data pipeline that turns pre-training documents into verifiable question-answer pairs, which preserves diversity while scaling volume. The left panel contrasts trillions of pre-training tokens with far smaller reinforcement learning sets. The central panel shows the 4 pipeline stages, from filter and identifier to generator and checker. The right bar chart reports consistent gains over the base model and continual pre-training across benchmarks. Alright, Figure 2 shows the Webscale-RL pipeline that converts pre-training documents into reinforcement learning data at scale. The flow starts with filtering to keep informative, self-contained texts. Then an identifier assigns a domain label and multiple personas. The central generator creates verifiable question-answer pairs using domain-specific few-shot exemplars, so the questions stay grounded. Checkers then verify answers and block prompt leakage, which yields a reliable reinforcement learning dataset. So while Figure 2 laid out the pipeline, Table 1 contrasts Webscale-RL with common pre-training, supervised fine-tuning, and reinforcement learning datasets. The pre-training corpora, like Red Pajama version 2, FineWeb Edu, and DCLM baseline, lists greater than billions of documents and multi-domain coverage, but no scalability rating. Sets such as DeepScaler and OpenR1 Math stay math-focused and offer low to medium scalability. The Webscale-RL row reports 1.2 million multi-domain pairs converted from pre-train and marked high scalability, which signals capacity to reach pre-training scale. So while Table 1 highlighted scalability, Figure 3 details what that scale covers. The left panel shows domain distribution. Math leads at about 21%, while lifestyle near 8.6% and commerce around 3.3% confirm coverage outside STEM. The right panel plots question embeddings. Blue Webscale-RL points spread widely, whereas red Nematron clusters tightly, which signals broader topical variety. Persona-guided prompts and diverse sources likely drive this dispersion. Alright, Figure 3 showed the dataset's breadth. Table 2 reports how that translates to results. The Webscale-RL row leads all 3 B baselines, lifting the macro average to about 52, so roughly 3 points over the strongest data refinement. Gains shine on MMLU Pro at 44 and Big Bench at 48, with Math 500 jumping to 58. Webscale-RL also narrows the gap to the QWen 2.57B base, reducing the average difference to about 6 points. Well, Table 2 showed broad benchmark gains. Figure 4 compares scaling of reinforcement learning against continual pre-training. The 3 panels plot MMLU Pro, Big Bench, and the 7 benchmark average versus training tokens. Reinforcement learning traces rise more steeply and sit above the pre-training triangles at every scale, which signals better data efficiency. With about 10 million tokens, reinforcement learning matches roughly 1 billion token pre-training on MMLU Pro, and around 100 million tokens bring about 4% average gains over the base. Wrapping up, 2 takeaways stand out. Converting pre-training documents into verifiable question-answer pairs unlocks reinforcement learning at Webscale, and the approach delivers stronger benchmark scores with up to 100 times fewer tokens. The broader implication is a practical path to data-efficient training, nudging model development toward reinforcement learning-first workflows. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.